All right, let's try this one more time. Welcome back to the Ranchcast. So tonight we're going to talk about breaking the monolith. If you'd like to join the conversation tonight, let me show you where. Screen share. And all right. So as always, I'm on Twitter, Jason Van Brackle. Most people call me JVB, and that's really just because there were lots of Jasons born between 1979 and 1983, and I'm just one of many. In addition to that, you can also join us on Slack. So if you'd like to join our Slack community, it is slack.rancher.io. Once you sign up and put your email address in there, you'll get an invitation to our Rancher users channel. And if you'd like to join the Rancher users channel, we're out on pound the Ranchcast or hashtag the Ranchcast or just the Ranchcast channel. So whichever you prefer, you will find us there. Say hi tonight. I'll check back to that from time to time. So let's go back to the monolith that we were talking about using. So from my previous video from just minutes ago, if you go to Four Guys from Rolla, and you just put in chat app, that y'all can find it. And it says building a simple chat app. So you can always go down here, and we're going to use this simple chat app. It is technically a monolith. It's a very small monolith, but it's what we're going to use to break apart for my example coming up later this week. And in this series, if it goes above and beyond just my time here at Tech Bash this week. So you can download it down at the bottom. Right in here, there's this download this chat app in zip format. Now, I've already gone and downloaded this on this machine. I have unblocked it. I've put it in IIS. And you can go back to my previous video on ASP Classic and Kubernetes, where I actually went and got this working on this machine. So this is already up and running. Let's take a look in IIS users. Sorry, I'm paranoid. I'm just checking to make sure that I'm recording. Yeah, I'm good. So back to IIS Manager, my really old chat app. My really old chat app here is running. Let's take a look at it. I'm just going to go to Browse. Oh, one thing of note, whatever folder you put it in, make sure here, I'll actually double check it. So we'll go here, and Explore. We'll explore this folder. So I put it on C chat. We look at this folder specifically around its permissions. If you're getting this set up, make sure this user, which is on Windows, will be able to read this app. Otherwise, it just won't work because IIS won't have permissions to read the folder, which is kind of a problem. We'll go ahead and close that, and let's actually take a look at this. So we're going to browse this now. //post, and I think it was default.html. So here's our chat app. And just to refresh the different actions, because we're going to have to capture each of these actions based on what's here in the code. So a couple things. We can see that when a new visitor joins, we get a message for there is a new visitor from their IP address. So let's actually capture that. This we'll need to test. Ooh, that's way too small for y'all. That's way too small for me. Nice and large tests. When a new user joins, message displays. What was it? We'll actually copy that. So it'll be the current time, the user, and a message. So time will be the current time. User will be guest. And message, a new user from IP of the IP. And this will vary based on whether they're IPv4 or IPv6. It'll also vary based on whether they're in Kubernetes. So because of the way CNI networking works, this was really hokey in Kubernetes. So this is not a useful feature for breaking the monolith, and we may just gloss over it a bit, just from a usability standpoint. That's test one that we'll want. Test 2 is we'll be changing the username. So when changing the username, when we put something in the username box and we send a message, all right, here we go. So changing these, so we're sending a message. All right, when sending a message, user displayed, that in the user input box, the message displayed is that in the message box, and time, the time is the current time. Those things I want to test for. And then there were two like secrets that I found in the code. One was, I think, /IP. No, that wasn't it. Just IP. It was IP. Okay. So when the message IP is sent, go to the IP column. And then when the message reset, that's the other one, if I remember correctly, hide the IP column. And that's, I think, our app in a nutshell. Yeah, IP, it is in, doesn't change the behavior state again. And I think resets the same way. Yeah, and that did that. I wonder if we do this. We do a JVB and send a reset. I don't think it does anything. Nothing new. Yep, that's fine. If I do IP, then it's that. Yeah, looks good. Okay. I just wanted to see what the boundaries were there. So we hide the IP column, no message displayed. And the same here, no message displayed. So those are the things we're all going to we have to test for. We also talk about what is going on with this application itself. So let's actually open these files here for a moment. Going back to IIS, content view, and let's take a look at each of these now, because we're going to break these based on how they're built now, and we still want them to behave pretty well, just based on how they're built, or at least we want to behave the same even as we're breaking them. And this is where we're going to have some trouble, I'm sure, because if I remember correctly, we have the default. Yes, let's browse into here. That's not what I wanted. Actually, kind of cool. We want to explore in here. Let's just open a VS Code window here. So what I'm thinking I'm going to do as I break this monolith up is the first thing is we're going to implement tests. I'll implement those tests either off screen or I'll start that process tomorrow. And then we'll also have to develop an API for this. So to break this monolith, we're going to use a pattern in domain-driven design, or DDD, known as the anti-corruption layer. If you want to know more about the anti-corruption layer, use our search engine, anti-corruption layer. And I believe Microsoft has a great document on this. So what we're going to do is we're going to treat an API that we're going to build as our new anti-corruption layer. So essentially, we're going to build the API here. And let's treat our monolith as if it's here, and our microservice is here. Now, we may not be breaking this into multiple microservices. Maybe we will. I haven't quite decided on our architecture yet. I'm going to draw that up probably tonight. And talk about where this is and where it's going. The important thing is that we're working with this legacy application, this old application. Actually, in this case, it's not a legacy application because we're going to assume this is an application that is in production, that's in current use, and one, has active development and needs new features, but two, also needs to be broken into microservices. So each API is going to have its own microservice. The anti-corruption layer is going to be the thing that holds all this together. So as we go, we're going to take pieces of this application. We're going to break it into microservices. So microservices will start filling in the API, and other legacy bits will start filling in the API as well. That's kind of how we'll attack this. So let's talk about the API that we need to generate to do this. Here we go. So let's have a new put it down here. We'll start talking about API. So we're going to have API. I guess, user, is it client? Let's just start with the messages. The messages are easier. So if we're doing a REST API, and that seems easy enough in this, we'll have messages. We'll have a message, messages. And then we'll have some sort of message object. And that will have, let's see, it has a time associated with it. It has a username associated with it. It has a message associated with it. And it has an IP address associated with it. And then the client joining is just a subtype of message. Really, it's just a join message. There is no concept of a user entity here. And then there's just going to be two actions here. Going to be IP, or let's call it show IP, and reset. So messages get will show all the messages. I don't know if there's a, and then put will be, oh yeah, post a message. All right, so we have our API stamped out, and we have all the tests that we'll have to run. So that's really it for the code tonight. Like I said, I'm gonna put us up a test framework. This machine doesn't have a whole lot of code tools on it because I don't code that often anymore. You see I do a lot of Terraform, but not a lot of C# and not a lot of web code. I've done a lot of that in the past, so picking it up is just a matter of me reading through the docs tonight and walking through a tutorial to do that well, and then picking a test framework. I'll probably go back to machine specifications. That's my favorite personally from my days of testing. But let me switch back to my main camera so we can talk for a few minutes. So let's talk about what works and what doesn't work. Well, that's too dogmatic. Let's talk about least possibility of success to most possibility of success, and a little bit of why. I've seen it done. I've seen breaking the monolith and application rewrites and things of this nature go different ways. So let me talk about the ways I've seen that don't work or that have a limited probability of success, and ways that will likely work or have a higher probability of success. So way one that doesn't work so well is the full rewrite. Actually, so we'll do subtypes. The full rewrite with two separate teams. There's a couple issues here. One is you have active development of the older version of the application and active development of the newer version of the application. So not only does the new version have to catch up with the old version, but the old version is going to have new features, or the old version has new features that have to go into the new version. You can see here the problem with this. And there's also a cultural problem that happens here because you end up usually either splitting the existing team or having two teams. If you split the existing team, one, you slow down development of the applicational features that are important to the user, and you've created a little bit of an us versus them because we have us, the team running the new cool thing, and them, the team that is maintaining the existing thing, or vice versa, us, them, whatever. And it really stinks to be the person having to maintain the old application, knowing it's going away, because you have questions now that rise around, do I get to keep, will I get to keep my job? Will I be replaced by this team? Will this team be adding new members that'll replace me? Like, there's a lot of things that can go wrong there that just demoralize the team working on the old application, or the old version of the application. And then the team working with the new version, it's, what if we fail? What about my colleagues who are working with the older version? How are we ever going to catch up feature wise? These are things that demoralize the team working on the new version of the application. So that's way one. Way two is, feature freeze on the old thing and just build the new thing. And then it's just the business comes back and says, hey, we need these new features. So that doesn't work so well. This is why I'm attacking it this way with the anti-corruption layer pattern, one piece at a time, because that allows us to have feature development on the older source code with full testing to make sure that it's still working. And then it allows us to also develop new features with new microservices filling in API calls, as well as to break the monolith one piece at a time. And this works really well. I've seen teams do this with success. It's just one of those things where it takes that, that two pizza team, or if it's not the two pizza team, it takes open communications. Getting bit by Conway's law, where your systems tend to take on the communication structure of the organization. So the two pizza team is great because you have cross-functional people all together, working on the same platform, and that works really well. So that's why I'd recommend the two pizza team. If you're in a siloed organization that's not going to build that, then at least build that as a communication structure where all the people are mutually accountable. Because that's the point of all of this, is that we're all mutually accountable to the products and projects we're building, not to fulfill client need. So we have members of engineering and DBAs and legal, and business subject matter experts and operations people, all working together, mutually accountable on the same project, to increase the probability of success. So that's the end goal. That's where we're headed. DevOps done well. DevOps is culture. I'll die on that hill. I say that a lot. So that's kind of where we are for the night. I'm going to work on some test framework and get my machine set up for either tomorrow morning or later in the day tomorrow, or sometime tomorrow. Like I said, I'm at a conference, got to be social, can't spend all my time in the room, gonna see some talks myself, and kind of go from there. So yeah, if you have any questions, again, feel free to hit us up on Slack if you want to join us. Again, it's slack.rancher.io. Fill in your email address, and then join us on the Slack users channel. Nobody out here tonight, but a lot more people watch these episodes recorded than see them live, but I always like the live back and forth. So with that being said, you all have a great night tonight. Have a great day at work. I may jump on midday or towards the evening again. We'll see. I've got 2 talks to prepare for this week, and maybe a talk tomorrow. Depends on the scheduling. There were some cancellations because of weather, out towards Chicago, and so some speakers couldn't get here, which really stinks because I've been stuck in an airport. It's not fun. Have a great night, and I will see you on the next episode. Bye now.